Hello everyone, in this video tutorial I will show you how you can train your YOLOv5 model to detect custom object. So I will show you how exactly you can create your dataset for training, how you can label them with bounding boxes. I will show all of them from very scratch. So let's begin. So first of all, to train models, of course you need some images and you need to label them, annotate those images. So I have this folder. The name of the folder is train data, and inside the folder I have images and labels. So inside this images I have two folders. It's train and val for validation, and in the train I have few images, and I have simply downloaded these images from internet. So it is 22 images for train and 8 images for validation. And here in the labels, the same way. Right now labels are empty, but I need to give labels here. These images and labels names should be as it is. You can give different name for train and val, it will work, but keep these images and labels because YOLO will search for labels folder automatically. That's why name this folder as labels and this folder as images. So once you've done that, inside that you can give any name these two folders. Just know which one is for train and which one is for validation. So this is all you need to know about this folder structure. So let's label these images. I have a website where you can do it very easily, and that website is makese.ai. Here you don't have to upload these pictures on server. It is done on JavaScript, so it is very fast. So click on get started here, and you can drop images here or can get images by clicking, but I will drop these images directly. First let's do the train images, and this 22 images loaded, and I need it for object detection, so click here. And this part you need to give the label names, and in this tutorial I will show only single label, single class label, and that would be second. And if you want multiple labels, then hit enter, and here you can write other things like this way, but I don't need it, so I'm deleting it. So now start project. Here you can draw bounding boxes around this sequence, and you have to select label, which is only one label here, so select that, and this is that easy. So if you want to edit labels, then you can go here, actions, edit labels, and you are in the label page again. Once you're done, simply click on this accept. You're done. So label these images, and for next image simply click from this window and do that same process again. So here we're done with these bounding boxes. Now let's export these labels. So for that, go to this action and export annotations, and here select this yellow format, click on this checkbox and then export, and these labels are downloaded, so simply extract those labels. And I'm deleting this zip file because I got this labels folder, and here these labels, names of those labels are from the image names, so all are here just formatted as YOLO expected. So for that, you can see what in there. I'm opening with Sublime Text, so you see here the first one is the class. Since here's only one class, so it is 0 always, and here 4 values for bounding box. So if you open that same file in this notepad, you will see that in single line you won't understand here. That's why I use notepad. Here you can see better. So copy all these labels and paste into the folder where we need. So here images and labels, in the labels, since this labels from the train, so paste it here, and do exact same thing for this val. And for that we need images of val. Now we're done with that, so refresh this page. Now we can start again from start. Here let's drop this val images. 8 images loaded, and label is again second. Start project, and let's do it again. So now we're done with image labeling, so close this website. Now we have data what we need. We have again images for train and for val validation, and the same way the labels here. And remember, this folder name should be labels because it is going to detect automatically this name. So our next step will be this. Since I'm going to use Colab for training this model, so let's open it. And to open Colab, I'm going to the GitHub page. There I can find the link for Colab. Here this is the official GitHub page for YOLOv5, and go little below. Here open in Colab. So let's connect Colab. So we are all set up in Colab. Now run our first cell. Okay, once you run this cell, it is downloaded this folder named YOLOv5, and we need to modify something in this folder, and also we need to upload our data into the Colab. So simplest way to upload is make it zip file, and for that do it this way, and you have zip file here, simply drag and drop, it will upload here. So as it is uploading, I will show you what file you need to modify in order to train from this images. So when you open this YOLOv5 folder, then you see this data, go in there, and this Coco 128 YAML. Now download this. And open it, and you can see the structure. We don't need this portion, anything, and we don't need anything that commented. And here you can see the first two, train and val. It is asking the file path where the train and validation images are stored. Anyway, first look at these class names. In original 128 Coco 128, it had this 80 number of class. So in our case, we have only one class, so it should be one, and here should have only one class name, and that is second. And we almost done here. Just need to provide this file name, file path. So before we do this, let's set up file here. So this is the zip file we just uploaded from our computer to Colab, this one, and we need to unzip it. So to unzip this, it should be like this. Now we are done. Refresh this. First delete this zip file, we don't need it anymore. Now we need to write this folder path here. So this is all we need to do. Now save it. Whatever name you want to give here, so simply do that. Custom data, like that. And now upload it to the same folder wherever downloaded from. Here it is. This is the file. Now I guess I have set up all the things that I need to. Let's go to the training part. Here is the code we need to run for training. These are some arguments you need to pass. This is the image size, this is the batch size, and this is number of epoch, and this is the data. And here we need to give our custom data. So this is the file that we just saved here, this one, custom data YAML. So just give that one, since this have the path there, path for this folder from where we have our custom images. And we almost done. So let's try with this 3 epoch first. Run this cell. And since it is running first time, so it is downloading this YOLOv5x.pt. Weights are downloading, so let's it download first. Okay, there is a small error. It says GPU is out of memory, so I think I should decrease the batch size. This time it seems working, so we have to wait until the training process is done. Even though the epoch size is 3, we need to increase epoch size at next time once this completes. So our first experiment is successful. This is trains our model in 3 epochs. So to really work that model, we need more epochs, like maybe 10 epoch or maybe 20 epoch. So I will try with 20 epoch and then I will show you result. So let's run it, and it will take little time, so I will show you when this is complete. So in 20 epoch our model could not learn, so I tried few times, and on 60 or more epoch, it need at least 60 epoch to get this accuracy. So on 60 epoch, see our result. It got 97 MAP, so it's a pretty good result. So if you see on the result from the run, the very last one, here are some result. So this is the label and this is the predicted. So let's compare these two. So you see predicted bounding boxes are pretty good, and the result is, this is the labeled and this is the predicted. So our model did pretty well. So let's run this model for this video. Here I have a video of sequence, and let's see how well it detects. So first of all, I need to upload it. Its size is 8 MB. So first upload it on this Google Colab, and in the predict part here, don't need this line. And remember, this weight, it should be the weight that is saved here from our result. This weight for prediction, and let's go to that place. Here simply replace this weight with our weight, and this source, go to back video.mp4, and I guess we set up all the things, and now run this. So this detection process is complete, and this is saved on this location. So runs detect exp4, go to there, and to watch this video we need to download it first. So video is downloaded, let's watch this. So as you can see, it had lots of false detection, and to resolve that problem, simply use this conf score. It give this confidence score higher, say 35%. So let's try again. So after sensing this confidence score, I got this video. So this might contain little better than previous one, so it will have little less false detections. As you can see, most of them are correctly detecting, even though this model is trained only on 22 images, and still it's doing pretty good. So here in previous time it was false detected here around, but now it is not. So this is all for this video, and if you like this video then please like and subscribe my channel. So thanks for watching.